Hi, welcome to geometry class. Today we are going to learn about two very special types of right triangles. We call them special right triangles. The first one's pattern is shown right here on our note sheet, but I want to kind of dive into a little bit of an exploration with you so that we can see if we can figure out what this pattern is exactly. Let's say that the shape I'm looking at is a square, and let's say that its side lengths are 5. All the way around, we have right angles, we have all sides are 5. Now, what if I wanted to know how long this diagonal was? Let's call it C because it's the hypotenuse of this right triangle. To find the length of that diagonal, I could use the Pythagorean theorem and go 5 squared plus 5 squared equals C squared. So 25 plus 25 would equal C squared. So 50 would equal C squared. And then if I take the square root on both sides to get the C by itself, to cancel out that square, I'll have the square root of 50. Now, depending on how much you remember from Algebra 1 or how much you covered in Algebra 1 last year, you might remember a little bit about simplifying square roots. 50 is 25 times 2. I mean, we just added 25 plus 25 to get 50. So you can think of it as the square root of 25 times the square root of 2. And the square root of 25 is 5 because 5 times 5 makes 25. So a simplified square root version of this would be 5 square root of 2 equals C. Now, you could also write that as a decimal, which you could have done with the square root of 50, which was 7.07, or 5 times the square root of 2, which is also 7.07, because those things mean the same. So 7.07 would be our approximation for the length of the hypotenuse C, which is the diagonal of our square. Now, let's say that I have a larger square here whose side lengths are 7. So we have all 4 sides are 7, all 4 angles are right angles, and I want to know how long is the hypotenuse of that right triangle, or the diagonal of that square. Well, I could do the Pythagorean theorem. 7 squared plus 7 squared equals C squared. So 49 plus 49 would equal C squared. So 98 would equal C squared. And then if I took the square root of 98 on both sides, the square root on both sides to get the C by itself, I would have the square root of 98 is equal to C. Or I could also think of the square root of 98 as the square root of 49 times the square root of 2, because 49 plus 49, 2 49s does equal 98. And 49 has a square root because 7 times 7 is 49, so the square root of 49 is 7. So 7 square root of 2 equals C. And if you did the square root of 98 in your calculator, you get 9.899. And if you did 7 square root of 2 in your calculator, you also get 9.899, which is the approximation for C as a decimal. So, do you see a pattern here? Notice when the side length was 5, the hypotenuse length was 5 times the square root of 2. And when the side length was 7, the hypotenuse length was 7 times the square root of 2. It just so happens that you could make the side length of the square be any number. Let's just say it's x. Then the hypotenuse of this right triangle, or the diagonal of the square, would be x times the square root of 2. You just take whatever number is on the side, multiply it by the square root of 2, and then you have the length of the diagonal of that square, or the hypotenuse of that right triangle. So if you had the length of the diagonal and you wanted to find the side length, to take the square root of 2 off, you would divide. Since you multiply by the square root of 2 to go from the leg to the hypotenuse, you divide by the square root of 2 to go from the hypotenuse to the leg. So, and since all these angles were 90, when you drew the diagonals in here, you create a 45-degree angle here and a 45-degree angle here, because we know, of course, that 90 divided by 2 is 45 degrees. So this is a 45, 45, 90 triangle. So that takes us to our properties of 45, 45, 90 triangles today. If you have the side length x, the hypotenuse is x times the square root of 2, okay? We multiply by the square root of 2 to go from the leg to the hypotenuse. We divide by the square root of 2 to go from the hypotenuse to the leg. So let's use that information to do some practice problems down here at the bottom. For number 1, it has the leg is 8. So to get the hypotenuse, I'm going to do 8 times the square root of 2. And I'm done. I don't have to do anything else. If I have the hypotenuse is 3 square root of 2, to go to the leg, I divide by the square root of 2, which means it's going to take that square root of 2 off. And I'm going to have the side length of 3. If I have the side length of 4, and I want to find the hypotenuse, I'm going to do 4 times the square root of 2. Now this one I have 18 is the hypotenuse. This is the longest side across from the right angle. So I have to divide by the square root of 2 to get the leg. If you just type 18 divided by the square root of 2 in your calculator, you'll get 12.7, which is fine. You can put that as your answer. That's an approximation. If you want to use your algebra knowledge to simplify the radical, you'll remember that you don't leave square roots in the denominator. So you multiply by square root of 2 over square root of 2. 18 square root of 2 over square root of 4. And the square root of 4, of course, is 2. And then you can do 18 divided by 2, which is 9 square root of 2. So 9 times the square root of 2 equals 12.7, okay? So I would take 12.7, I would take 9 square root of 2, okay? If you're thinking you're going to go into some more advanced math classes later on in high school, you may want to work on this, because this is something that you should have learned in Algebra 1. But if you're going to stick with some of the more basic maths, then that 12.7 is fine, okay? So let's see, number 5 would be just the same as number 4, because we're given that hypotenuse, asked to find the leg, and the hypotenuse doesn't have the nice little square root of 2 already on it like number 2 did. So we have to go 16 divided by the square root of 2. You can do this in your calculator, which will give you 11.3, which is fine. Or you can do this to get a simplified square root number, multiply times square root of 2 over square root of 2. So that's going to be 16 square root of 2 on top over square root of 4 on bottom. The square root of 4 equals 2. So 16 square root of 2 divided by 2 is equal to 8 square root of 2. So that's going to be the answer if you want it as a simplified radical. 8 square root of 2 is 11.3. Same thing. All right. Number 6, 24 square root of 2 is the hypotenuse. This one's like number 2. If you're dividing by the square root of 2 to go back to the leg, that square root of 2 is going to come off, and it will just equal 24. All right. The next 3 problems are like little word problems. They don't draw the picture. You might want to draw the picture to find the answer. If a 45, 45, 90 triangle has a hypotenuse of length 12, find the leg length. So we're going to do 12 divided by the square root of 2, because we're going from the long side to the short side. 12 divided by the square root of 2 is equal to 8. Let's just say 8.5. Rounding to the 10th place there. All right. Number 8. Determine the length of the leg of a 45, 45, 90 triangle with a hypotenuse of length 25 inches. So this one is just like the last one I did. 25 is the hypotenuse. We want to know the leg. We go 25 divided by the square root of 2. 25 divided by the square root of 2 is 17.7. And now this last one, find the length of the hypotenuse of a 45, 45, 90 triangle. 45, 45, with a leg length of 14. Well, the hypotenuse is going to be 14 multiplied by the square root of 2. And that one is done. All right, we have another special right triangle that we're learning about today, which is called the 30, 60, 90 triangle. So, before we jump into the notes on this, I'd like to kind of do a little exploration with you. Let's say I'm looking at an equilateral triangle. We learned about equilateral triangles already this year. And let's say that each side of my equilateral triangle is 10. And let's say, well, we know that all three sides are 10. All three angles are the same on an equilateral triangle. Do you remember what they're equal to? The triangle adds up to 180. If they're all the same and you divide it by 3, they're 60 apiece. So we've got a 60-degree angle here, 60-degree angle here, 60-degree angle at the top. All three sides are 10. All three angles are 60. Now, let's say that I want to draw the altitude of this triangle, the height of this triangle. That means I'm going to split it right down the middle at a 90-degree angle. So if I did that, how many degrees would each of these two angles at the top be, since I split the top 60 in half evenly? This would be a 30, and this would be a 30. Okay, we got 90s at the bottom. Now, how long are each of these little short pieces that I've split my big long bottom side into? Well, the whole thing was 10. And if I split it into 2 equal parts, this is 5 and this is 5, isn't it? Now, if I wanted to find the length of this height of my special right triangle, I could use a squared plus b squared equals c squared, or here h squared for height plus 5 squared equals 10 squared. So h squared plus 25 equals 100. And if I subtract 25 on both sides, h squared equals 75. And now I want to take the square root on both sides to get the h all by itself. And I remember that 75 is 25 times 3. Like if I have 75 cents, that's the same as 3/4, right? So I could call that the square root of 25 times the square root of 3. And 25 does have a square root. It's 5, because 5 times 5 is 25. So 5 times the square root of 3 would be the hypotenuse here, okay? So it turns out there's this pattern on a special 30, 60, 90 triangle where if you take your short leg and you double it, you get the long leg. And, I'm sorry, you get the hypotenuse. The short leg doubled gives you the hypotenuse. The short leg times the square root of 3 gives you the long leg. So we have this pattern listed here. The short leg is x, the hypotenuse is 2x, and this long leg is x times the square root of 3. Okay, I want you to keep in mind, you multiply to go from a smaller side to a longer side, you divide to go from a longer side to a smaller side. Multiplying will make a number bigger, dividing will make it smaller. So we need to keep that in mind when we're doing these problems. All right, let's look at some practice problems. I'm going to put the little pattern up here at the top. I'm going to draw my right angle here. This is my 60-degree angle. This is my 30-degree angle. I have x square root of 3, and 2x. okay? So this problem number 1, I'm given the length of 1/2. That's on the short leg, the shortest side. It's across from the 30, so I know it's the shortest side. And then I'm going to double that to get the hypotenuse. What's 1/2 times 2? 1/2 plus 1/2 is 1. So this is 1. And now I'm going to take this short side, 1/2, and multiply it by the square root of 3 to get the long leg. So that one is done. Number 2 is just the same. This is the 30-degree angle. The 8 is the short side. It's the one across from the 30. It's the littlest one. It should look like the littlest one in the picture. You double this to get the hypotenuse. So 8 times 2 is 16. And then you multiply that short leg times the square root of 3 to get the long leg. Now, number 3, they've pulled something funny on us. They didn't give us the short leg this time. We're trying to find the short leg. They gave us the hypotenuse, okay? But remember, the hypotenuse is double the short leg. So if I want to know the short leg, I'm going to divide by 2. 11 divided by 2, we know, is 5.5. So the short leg is 5.5. I'm going to take the short leg and still multiply it by the square root of 3 to get the long leg. All right, number 4. On number 4, they gave us the long leg. It's the one across from the 60. It's 9 square root of 3. We divide it by the square root of 3 to go to the short leg. Okay, so basically you're going to take the square root of 3 off and it's just going to be 9. And then now that we have the short leg is 9, we double it to get the hypotenuse. 9 times 2 is 18. All right, number 5. They again, just like on number 4, gave us the long leg. But this one had the square root of 3 on it. This one doesn't. So we're going to go 12 divided by the square root of 3 to get the short leg. 12 divided by the square root of 3 is approximately 6.9. That's as a decimal approximation. If you wanted to do a simplified radical, you can do that. You would multiply by the square root of 3 over the square root of 3. So 12 square root of 3 over square root of 9, because 3 times 3 is 9. The square root of 9 is 3, and 12 divided by 3 is 4. So 4 square roots of 3 would be the same thing. We could type that in, 4 square root of 3, okay? That's some advanced Algebra 1 skills, so if you just want to give me the decimal, I'm fine with that. Then we're going to multiply it times 2 to get the hypotenuse. So take my answer here, times 2. Oops, I hit it twice. 13.9 would be the length of the hypotenuse. That's 6.9 times 2. Or if I did 4 square root of 3 times 2, that'd be 8 square root of 3. And you can see if I do 8 square root of 3, that gives me 13.9 also. Same thing. Either answer is fine. I don't need both. All right, number 6 is like number 3. They gave us the longest side, the one across from the 90, the good old hypotenuse. The hypotenuse is double the length of the short leg. So if I take that 20 and divide it by 2, that's going to give me 10 for my short leg. And then I'm going to take my short leg and multiply it times the square root of 3. 10 square root of 3 will be the long leg. Okay, number 7 says an equilateral triangle. Let me draw a little equilateral triangle over here on the side. Has an altitude length of 36 feet. Altitude and height mean the same thing. Okay, and this is a 60, 60, this is a 30, this is a 30. Determine the length of the side of the triangle. Okay, well, we're given the long leg, so we have to divide by the square root of 3. 36 divided by the square root of 3 gives us the short leg. That's 20.8. I'll round up to an 8. And then I'm going to double this to get the hypotenuse, which is going to be the length of the side of this equilateral triangle. So times 2, 41.6 is the length we're looking for here. That's the answer to the problem. Okay, number 8. Find the length of the side of an equilateral triangle that has an altitude length of 45 centimeters. This is the same kind of problem we just did. 60, 60, I'm going to draw that altitude, that height on here, it's 45. This is a 30-degree angle, this is a 30-degree. And we're trying to find the length of the hypotenuse of our right triangle, which is the same thing as the length of the side of the big equilateral triangle. So we're going to start by taking the length of the long leg, 45, and dividing it by the square root of 3. So that's going to give me, 8's going to round that up to a 0, which will carry over here. It's going to be 26. And then we're going to double that to get the hypotenuse of our 30, 60, 90 triangle. And that's going to round to 52. So 52 will be the answer. Okay, that's our lesson for today. Good luck on your assignment. Please let me know if you have any questions or if you need any help. Have a wonderful day, and I will talk to you soon. Bye for now.